Good evening, everyone. Welcome to Le Wagon. Who among you is here for the first time? Okay. And who doesn't know what is Le Wagon? Okay, just a few people. So to make it short, Le Wagon is happy to welcome you tonight to this machine learning workshop. Le Wagon is a coding school for entrepreneurs. It turns them into amazing developers in 9 weeks only. If you want to know more about it, just ask me any questions you have at the end. So now I'm gonna introduce you to David Leroy, who is going to make the presentation tonight. And so it's gonna be around, what, an hour?
Yeah.
And at the end, you'll have the opportunity to ask any questions. So come and wave at me and I will give you the mic. So thank you very much. Have a great evening.
Yeah. Cheers, thanks. First of all, thank you all for being here. Actually, it's great having so many people for this talk. Tonight we're not going to talk about much fancy things, like we're not going to talk about petabytes of data digested in 2 seconds or this kind of things. This talk aims at being very practical and get you from 0 to 1 and not just from 0 to 1,000. So my name is David Leroy. So at the moment I'm doing freelance in data science. Prior to that I was heading the data science and product engineering team at Equimetrics. So we are doing both machine learning like data science project and software engineering, mostly in Ruby on Rails. So yeah, I think we can just get in it. Do not hesitate to interrupt me at any time, like really. It's supposed to be like a discussion, not just a one-man show. So let's dig in. Aim today would be just for you guys, if you don't know anything about machine learning, that at the end of the talk you'll have like just a few key takeaways to bring with you at home. First one would be just to get the fundamentals about what machine learning is and what kind of task it can actually solve. Second one is just the when and how thing. So great knowing a little bit about it, but just when am I supposed to use it and how to get started, like how to get from nothing working to actually getting something pretty simple that works. Third part of this presentation would be more about machine learning in action, so seeing things getting done. Just showing you that there are some pretty simple things that you can do to start with, which doesn't mean that machine learning is an easy thing. I'm far from that, but you can actually get started with pretty simple things. And last but not least, where to dig for more. I mean, in an hour, I have no ambition of saying anything very smart. It's just like a wrap-up of what I wish I had been taught when I just got into machine learning. So it's just like the very, very beginning of a pretty long learning curve for you guys if you want to get involved. So let's start with the fundamentals. What I mean by fundamentals is just trying to understand where machine learning fits in the computer environment, I would say computer science environment, and actually why is it called learning? Like you have actually a few similarities with the way we think, like as humans, and what is different from like other kind of computer algorithms. So to start with, we're just talking about the human learning analogy and how you actually, it's okay, like the sound? Yeah. How you teach kids, for instance, you teach kids to recognize cows from horses. So it's like very, very standard example where just, at first when you're just born, you don't know how to differentiate a cow from a horse. Then an adult will come to you and say, hey, kid, look at this picture. It's a horse. And hey, kid, look at this picture. It's a cow. It may actually take you some time as a human to get to understand like what specificities make an animal a cow or make an animal a horse. But in the long term, you just get to build like a decision function in your mind, which will tell you how to differentiate one from the other. Basically, machine learning is exactly the same idea. It's just bringing samples of data to computers with information saying, like, this is a cow, guys. Yeah, you have just like thousands of pictures of cows, and you have thousands of pictures of horses, for instance, and you would just say to a computer, like, now you're gonna have to learn to differentiate cows from horses. Okay. So that's the very basics. That's why we talk about machine learning, because it's actually building a decision function to differentiate cows from horses. Okay, now, just something that I'm trying to explain. Let me know if it's not clear at all, but I was at a talk last week of personal development, and I was introduced to a concept which I didn't know about before, and it's the way our brain works. It's called the fast and flow peace of mind. So basically, our brain works in two ways. You have system one thinking and system two thinking. System one thinking is a part of our brain which takes very rapid decisions based on data, actually our sensors. So system one thinking is basically habits you have. So you are able, like your mind is able to figure out how to take a decision very rapidly. Okay. So it's basically a set of rules that we learned. If we get back to the horse cow example from before, it's basically once you've learned how to differentiate them, then in less than a second, for instance, you'd be able to say, hey, it's a horse, hey, it's a cow. System two thinking is actually the part of our brain which processes like most difficult tasks, especially learning new things. So system two thinking is very good at inferring new rules from experience, okay? You can think of machine learning pretty much the same way as system two thinking for computer science. Let me explain. In computer algorithm, you would have what we call rule-based algorithm. It's just what most of us know. It's hard-coded in a way. So it's the code you would make out from loops, from for, from if, from while. This involves a knowledge of what the output you're trying to reflect with your function, for instance. On the opposite, kind of, machine learning is just inferring this decision function, so from experience. So it's just ingesting data, and it figures out by himself what these rules for decision are, okay? So you can think exactly of the same way as machine learning to rule-based algorithm as system two thinking to system one thinking for human, okay? So a child will just infer rules that differentiate a rose from a cow from a horse, and then it would become system one thinking, like, you know, on the spot how to differentiate horses from cows. Machine learning basically is just, you would infer a set of rules that you could just then apply on the fly to differentiate horses from cows the same way. Okay, that's it for I would say our introduction and analogy to the way we actually learn things. Now, I think it's like part of the fundamentals is understanding what kind of task you can actually solve using machine learning. I'm telling you that up front here is just like a simplistic vision of machine learning, but it's a good framework to start with to get to understand what we can do. You have like three kind of tasks that you can, three major ones. You have regression. So basically regression, I think you guys have all seen it at school at some point, is just predicting the value of an output, which is continuous. So for instance, you have a business, you want to predict how many bags, let's say you sell bags. You want to predict how many bags you're going to sell in the next 2 weeks, like in the coming next 2 weeks, based on your past sales data. This is regression. Next one is classification. This is exactly the horse cow example that I talked to you about, okay? So it's basically being able to say, this one belongs to class 1, this one belongs to class B, okay? Class 1 could be cows or horses, cows for class 1, sorry, and horses for class 2, but it could also be this email is spam or this email is not spam. So this is an example of classification as well. And third one is a bit different. It's called clustering. Clustering is just grouping similar items together. One good example of that is just, let's say you have a consumer database. So you have like, you've built a business and you have like 2,000 consumers, and you'd like to get to know what groups of consumers do you have. And clustering the ensemble of methods enables you to build groups of similar users. Now I think it's just to get a better understanding of that. We're just going to illustrate that with a few examples, both from real life, kind of, and then from like business life, I would say. So we just talked about differentiate cause from horses. So it's definitely a classification problem, okay? You want to be able to classify them. Another example would be just trying, let's say you're just sitting in a restaurant and you don't have access to the menu, so you don't know how much it costs. And based on your context, so where you stand, like the kind of restaurant, like how the waiter behaves, you'd like to know, like to estimate how much it's going to cost you, okay? So in that case, the output would be just more like number of euros it may cost you. So it's a regression problem based on a set of features. You want to tidy up your room or your kid's room. You just want to group things together so that it actually makes sense, so that you can find them later on. In that case, you want just to group things that make sense together. You're going to put books with books, maybe CDs with books, and then on the other side you may have like, I don't know, like your old electronic devices that you'll put in a single box, and on and on. So this is a clustering task, okay? Another question would be like, will there be a taxi to get me back home at a given time in a given space? In that case, it can actually be seen in different ways. It can be a classification problem, like, will there be at least one taxi to bring me back home, or 0, like 1, 0? Or how many taxis would there be at this given moment, at this given space, to bring me back home? And in that case, it becomes a regression problem. Okay. Now, business-related decision-making. I mean, it's maybe a bit heavy on that part, but I think it's a really important part because it's just like the basics in order to get to understand what kind of model you'd like to develop later on. Classic customer relationship management question, which is actually not very well answered most of the time. Who are my clients? When I mean who are my clients, what are they interested in? What are their purchasing behaviors? And so on. This is basically a clustering question. Who should I send this marketing campaign to? You have a limited budget for a marketing campaign, and you know you just can't send a letter to all of your customers. And you're just trying to figure out to which customers it makes more sense to send the letter to, okay? This is a classification problem. You just want to get to know, like, who are your customers who are the most susceptible to actually open your message and to actually convert, hopefully. How many items am I hoping to sell this week? So this is definitely a regression problem in that case. Okay? Make sense so far, or? Yep? No? Tell me, yeah? So now let's dig in a bit in these three concepts. Here I'm taking every example, I'm taking like kind of tabular data, like the same one you would have on Excel. I think all of you have worked with Excel at a certain point in your lives. Just to get to understand that it doesn't necessarily have to be like in a database or in something that may seem far from you, it's just data from the real life. So regression task is just predicting a continuous output based on a set of inputs X, okay? Let's have a look. We're talking here about our previous example, so the meal price estimation. You would have meal prices on the left, so these are data points that you gather during your own experience. You went to a few restaurants, like let's say a few hundreds, and you collected that when you were there. So depending on the number of courses you took, the location you were, how the waiter was behaving with you, you could just like kind of you just track all that, okay? And now you'd just like to know you're in a new place, you hadn't access to the menu yet, so you don't know how much it costs. And you're trying to figure out how much it may cost you, okay? So what I'm just doing here is just considering only the first variable, so the number of courses variable, regarding the output meal price, what I'm actually trying to predict. Let's say our points are distributed like that. So here I'm just like plotting my cross represent a row in my database. What I'm trying to figure out is just a decision rule here that would enable me for a new given X on the horizontal axis, which expected like meal price I would have. Okay, so let's say I'm taking 2.5 courses, doesn't make sense, but how much am I expecting to pay? It's only two-dimensional, but You could imagine that in 3, 4, 5, up to 1,000 dimensions if you want. It's just that it's easier to think about in a 2D plan like that, I think so. So basically, our regression here would be just fitting like line and saying, this is my inferred rule. This is the rule I'm going to use later on to predict like the expected meal price, okay? So building this inferred rule in machine learning is called like fit, okay? Train, fit. And then you can use this inferred rule to predict a new use case, okay? So in that case, it would be, for instance, I'm taking like 3 courses in the 8th arrondissement with gentle waiter attitude and very verbose menu, okay? And I would expect like a 65 euros cost. Now classification. Classification is predicting a categorical output Y based on a set of inputs X, okay? So same use case, we're taking tabular data. This time Y is just 1 if you have at least 1 taxi available, 0 otherwise. My variables are just like time and space variables that are depending on where I was at this precise moment, okay? So here I have time of day, like shop density, which is just a proxy for if it's an area where you have a lot of shops or no, and nightclub density, if like it's where people tend to go out or not. Special event could be, for instance, is it like the fashion week or not, okay? 1 meaning it's a fashion week, 0 it's not. So again, let's do a 2-dimensional plot here in order to get a sense of it. It's pretty different from the last one, actually, because here, you see on the horizontal and vertical axis, I have variables. I don't have my output Y, okay? I'm just representing here, in green, the data points where I have no taxi, I have at least 1 taxi available, okay? And in red, I had no available taxi. Classification is figuring out a way to split this plan in such a way that you would have all green crosses in one part of the plan and all red crosses in the other one. So basically, it would be inferring like a separation between green and red crosses. Here, I've purposely left a green cross in the red part and a red cross in the green part, because most of the time, it's pretty harsh actually to find a perfect separator. So in many cases, you're not perfect on predicting which label is assigned to a specific data point. So in that case, in some cases, I would say, hey, there won't be any taxi for you, sorry. And there'll be. On the other side, you could have, there weren't supposed to be any taxi, but you found one. This is a kind of mistake that you can do with classifications. Same as before, it's a fit predict paradigm, kind of. So on historical data, you fit your model, and then you're able for a given user at a given space at a given time to predict whether he'll find a taxi or not based on this data. Okay. That's it for classification. Is it like clear? Yeah. No. Let me know like seriously if something isn't. Now clustering. Clustering is a bit different from what we saw so far, because it's actually not a predictive modeling. It aims at identifying groups of similar items from inputs. So I'm back to the client database example. Okay. So here one row represents a client, and you would have a few attributes about each client. So when was its last purchase? So let's say 2 weeks ago. How many purchases did he do in total? Average spending per purchase. So is it spending a lot each time he comes to your shop or not? And top category, what he's mostly interested in. If we take the first 2 variables, then we can plot our data points this way. And clustering, the main idea behind clustering is just to group points that are very close one to each other in such a way that they are actually close one from each other, but away between clusters. I don't know if that makes sense. There's just a you could have just classified your clients by saying all people who spend less than 30 euros and have about less than 10 things would go in a specific cluster. Here, you're not guessing anything. You're just asking mass to do the job of building clusters of your clients. Okay. So in that case, you're not trying to predict anything. So it's only a fit. So at the wrap up of this first part, I hope it's not too long, but so machine learning is actually training computers at learning rules to answer 3 kinds of tasks. So regression, predicting the continuous output. You would also have classification. In that case, it's not continuous, it's categorical, based on a set of inputs X. These 2 tasks are called supervised learning. They are supervised because you have actually access to Y. So you know what you're supposed to predict. You have a data set containing both the Y and the X. Okay, so you know all of it. In the unsupervised case, so it's clustering. In that case, you're not trying to predict something. You're just trying to identify, like to find patterns in data. You're looking for a way of understanding a big data set that you can actually look at with your own eyes. It's a pretty different way of seeing things. So that's it for the fundamentals. Hopefully it was clear. Now, it's more about the when and how. So it's maybe, I don't know what you guys are doing in a daily basis, but I think it's more the part where entrepreneurs or people who are wondering whether it could be of interest to them may be interested. So when several things that are highly misunderstood, I think, in this like kind of machine learning industry, is just, do you have the basics in place? When I was working at Equimetrics, we were working like with a lot of big corporate clients. So we were building like machine learning application for them, or even just like small apps with no intelligence, depending on the cases. And some of them were coming to us and just saying, "Hey, I want you to build me something very fancy with a deep learning library or something like that." But we are just asking, what is it supposed to do? Like, what the end purpose of that? And in many cases, well, when you start talking with them, you get to understand that they might not have like accurate historical data, or they haven't stored them, or they actually don't manage to they've stored them, but they don't find them anymore. So data collection and storage, just like, if you don't have that, is in most cases a no-go for building anything with machine learning. Other thing which is pretty important is that in many cases, just having the right metrics to look at your business is enough. So reporting is actually very important, and building the right metrics is also very important. And checking the rule of thumb is also important. I mean, like, if you haven't taken any time to think about something and trying out to figure out a way to solve it with like something simple, machine learning is not your solution. Like, it's not the solution to any problem. It's just something that may help you do something smarter once you've get to understood what it's about. That's the way I see it, actually. Is your task subject to externalities that you cannot model? I think, like, for instance, obviously Google is amazingly good at machine learning. There are many reasons for that. One of the reasons is also that the subject they tackle is kind of stable across time. If you're trying to do, for instance, picture classification, like, your picture today and pictures tomorrow are not going to be strongly different. If you try to model a business, for instance, and you have like external factors such as, I don't know, macroeconomics, that can deeply impact your business, then it's very different, because you may manage to build a model that makes sense, but as soon as it's stressed out by an external factor, it can like totally break. And it's a thing to keep in mind. It's just that it's not like magic, so you have to like be clear that it's not because it's a prediction that it's going to happen exactly this way in many unstable cases. Last but not least as well, how do you evaluate the task? Is it like critical for a business? What I mean critical is just, can you afford false prediction? Are there cases where it's just not possible? You can't tell something to a client that it's false. And The thing is just your models will get better, but in most cases, you still produce like errors. So you have to take that into account as well. So this is the when. Now the how. Two things that actually look pretty straightforward, but in many cases are not. Defining the problem and provide meaningful data, okay? So define the problem is just, we're just talking about regression and classification. It seems pretty easy like that, but what output are you trying to predict? Let me just talk about an example, like predicting whether there'll be a taxi available at a given time, at a given space. It may look pretty easy when you look at it like this, but actually, what do you mean by at a given time? Is it like in a 5 minutes time frame, in a 10-minute time frame, and in a given space? Is it like just at the point you stand? Because it's not very likely that it's going to happen. Is it like in a 55 meters range around you? And defining all that is very important to defining like a learning task, because if you haven't like a strong belief in the output you want to predict, you may build a model that in the end doesn't bring you anything because you can't trust it. Second thing is just, what is a performant model? Something else which is highly underlooked in many cases. Performance is not absolute in many cases, it's relative. If I'm taking again the taxi example, I'm defining like my Y as I have a taxi in a 100-meter range within the next 10 minutes. Okay, it's defined. And then I'm having a look at my data, and I see that in 98% of cases, it actually happens. I'll find a taxi. So my performance baseline would be 98%, because if I'm always saying there'll be a taxi, then in 98% of cases, I'm right. Which actually means that when you do your modeling, you need to keep in mind that this is what you're supposed to beat. It's just not you're fighting against zero, like I can't predict any good cases. You're fighting against this baseline. And I think it's a pretty important fact to keep in mind, and that it happened to my team. We had a lot of cases where we just like, yeah, actually it's sexy, but it doesn't work. Provide meaningful data. Meaningful, two factors, quality and quantity. Quality is just, you're not gonna predict like a high school student rating based on his color hair. It's much more like complicated than that. So quality is actually bringing the right variables within the models. In many cases, like it seems very straightforward, but it's again not so much. It's very important to think about what you're trying to model in order to build the right variables to get into it. And quantity, it's actually highly dependent on the task you're trying to do. But in many cases, your data will become better if you have a lot of historical data. Your model, will become better if you have a lot of historical data. So ain't no magical trick here. It's just like it's powerful, but it has to be handled with care and has to be smartly thought of. So it's definitely something that is underlooked in many cases, I think. Now, a meaningful model. Here it's much more about model performance. If we're back to our brain analogy, learning algorithm can do exactly the same as what we call bachotage, which is just learning by heart, like the answer. So you learn by heart the answer, but you haven't understood shit about anything, you're just like learning by heart. A learning algorithm is supposed to generate like a rule which will explain a phenomenon and represent that phenomenon. So overfitting is just learning by heart. So your algorithm just predicts everything very well, but as soon as you get an edge case, something you haven't like learned by heart, then you're unable to predict anything. Let me show you what it looks like. For instance, if we go back to our meal price estimation, the green cross here is a data point that I've kept away for model fitting. So it's something that I'm not using to actually estimate my rule, and that I'm going to use just to check if my model is working or not. Okay, it's going to get clearer, hopefully. So this is basically what an overfitting model would look like. It fits perfectly all my data points. But as I'm looking for the predicted value for my point here, you see that the real data point is very far from the prediction. So you get like a very, very precise fit on the data points you've built your model upon. But as soon as you're trying to predict a new data point, then it just doesn't work. The one way of solving that is actually to build your model only on a few of the existing data points and not all of them. So this would give you that, actually, and you could like generate another sample of points that you would use, and it could give you that. Okay. So basically, what we call cross-validation in machine learning is just making sure that your performance is stable and that you're just not overfitting by just switching the points you're training and testing on. Okay, don't know if that makes sense. Now, because it's supposed to be a workshop, I'm gonna have enough time for that, but technology choices, how do you make it happen? How many of you guys are like Ruby on Rails developer? Yep. It's a lot. Not too much for a talk at Le Wagon, I think, but how many of you are involved in technology, like any product management, like IT development, like the software developers? Okay. I think it's actually constraints that are shared by a lot of like computer science things. One of the main constraints that you'll have to take care of when you build a machine learning model is whether it's one-shot, batch, or real-time. It's pretty straightforward, but let's assume you have a company that for which it's really important to know the gender of their customers. Okay. The thing is just that in many cases, they don't manage to know the gender of their customers. So when someone comes in store, like the cashier, for instance, she doesn't think of taking like the gender, she just takes the name. Okay. 3 different situations. You need on a yearly basis to provide your manager with just a breakdown of girls versus men buying your stuff. This is a one-shot. So you just have to fill in the blanks for all the genders missing on a yearly basis. Okay. Second use case would be batch. You have a weekly reporting that tells how many new subscribers are women and how many new subscribers are men. In that case, you would have to run that on a weekly basis. So you'd have to make something a bit much stronger because you don't want it to crash every week and just to deep dive into it. Last one would be real time. This time your company, I don't know, is just a dating app, for instance. And your dating app, when it's pretty dumb, when you subscribe, you tell your name, you tell whether you're straight or gay, but you don't tell your gender. In that case, you want to push the right recommendation straight away for potential matches. You don't want to wait like a week before you actually push something to your customer. So in that time, it would be a real-time machine learning where you'll have to predict the gender of your customer based on his name, for instance, or his social account like Facebook, or if you do things like that. Second one, obviously, like in every computer science problem, is just scale and model chosen. Like model complexity can vary a lot depending on the choice you take. In many cases, like at scale, a lot of people choose simpler things if they can. And you may not want to go the hard way early on. You may want just to stick to simple things and do simple things as long as you can. And the day it actually really makes sense for your business and that it brings clearly more value, then you may go actually building something bigger. And finally, production ready or not. Yesterday I was listening to a conference by a tech guy at Spotify who was saying like they basically coded all in Python in the first place and just had to rebuild everything from scratch later on because it wasn't really behaving well at scale. So it's exactly the same here. You don't have any golden rules, but lots of big companies have just stopped using high-level languages and and went the other way, like most people do. They just code in Java or C++ at the moment because it's the best way to scale a big system, actually. Now in action, let's go. First thing to understand, exactly the same way you're not alone when you develop a web app. You're actually not alone when you develop machine learning application. I don't know if the environment is as rich as it is in the software engineering world, because it's pretty amazingly rich. But you'd have the same kind of graduation from full custom to managed services. So if I'm drawing the arrow here, and I'm starting from right, because we're always looking for on my side actually, I'm always looking for the easy solution before actually getting really my hands on. You have fully integrated services. You have, for instance, Dataiku. I don't know if there's anyone for Dataiku here, but they're providing like a software where you can actually build your model from end to end and just click and deploy. You would also have like specific vertical driven machine learning softwares. For instance, Custora is just like focused on CRM, and they do predictive modeling for customer life value, like clustering, this kind of thing. So this is like the fully integrated part of it. It would be kind of a CMS for web development, like you just take WordPress and you plug in your stuff. And then you would have machine learning APIs. So basically a RESTful API is exactly the same way you would use like RESTful APIs in Rails for a lot of things, I think. Like you have machine learning APIs like dedicated to images, videos, texts, like to basic stuff, like the one I'm going to show you after. So basically, just integrate in your app without having you to actually deploy any instance for running your machine learning codes on your own. You can do that with other people's machines. You have libraries. I think if you guys do a bit of Ruby on Rails development, you know that you're going to look for a library before recording everything. Same thing applies here. And then the full custom, like you just record everything. And I actually love people do that, because at a certain moment in their life, it doesn't fit to their needs. So they have increased in maturity, increase in specificity, and it's getting harder and harder to match their needs with the existing stack and existing technologies. So they basically do their own stuff. I've never done that, but it's a bit long. I don't know if you have to read that, but it's just, I think there are kind of the conflict between two different worlds here. Machine learning in itself, without embedding it in a product, is kind of limited on a business perspective, like from business standpoint. And it's not, most of the times, I think it's going to change, but it's not your product engineers or your backend developers that actually build machine learning models. And it leads to a real mismatch between what mathematicians did on one side and what you can actually productionize on the other. And that's actually something that is very important to keep in mind. It's just that building intelligence is great. Building intelligence that you can actually embed in the product is better. So here is just words from Robert Chang and Jeff Magnuson, who say more or less the same thing. It's just keep in mind that it's great building a model. It's even better if you can do something with it. Okay. So I've prepared two very small examples. First one is just a machine learning classic. It's just person houses pricing. Our aim here is just based on data set of historical data about prices of the houses in the suburbs of Boston, to build a model that is able actually to predict for a new Boston suburb district, like the average prices of houses. Okay. So it's a very old data set actually. So prices at the time were between 5 and 50K for a house in dollars. So I don't think it's the price that apply anymore. But like in average, you have it costs $22K, and what we're trying to do here is just estimate, build a regression model that will enable you to, given a set of inputs, predict the price in this area. So I'm just going to do it like 2 different ways, just to show you that on the managed side of it, you can do stuff without actually coding anything. While preparing this talk, I discovered actually the powerful add-on, which is called Smart Autofill in Google Spreadsheet. I have never heard about. Basically, what this does, you can select your data here. So here are all my variables. I'm not going to get into details. I don't think it's the purpose now, but I'm just going to take all my variables. Oh, shit. My bad. Up. So we're trying to fill in the blanks, and Google has built, it's just crazily simple. You just do Smart Autofill Start. It's a plugin you need to install. Okay? It's just figure out like your data structure, next, and then select the column to autofill, column C. I like predicted value, and there you go. So it's basically not more complicated than that. It actually works pretty well for classification and regression tasks. Okay, no model found. Not two great examples. It worked for a few of them, but it's still a bit buggy, obviously. Sorry, Google, not a great job at that. But basically what it does here is just Google has something called the Google, it's going to drive me crazy, as the Google Prediction API. The Google Prediction API is just a way to host your model at Google. You just provide them with data, and they build the model for you, and then you just call it whenever you want to. So this is just a plugin that they've built for their own Google Drive to call the Google Prediction API. It doesn't work perfectly yet, but if you're just doing like the one-shot kind of thing, it's just something you may look upon. Second thing, I don't know if any of you here are using Amazon Web Services. No? Yes? How many? No? So Amazon Web Services is like a massive cloud provider. And they've built something which is called Amazon Machine Learning. It's actually pretty amazing because you just drop your data in like somewhere on S3 on Redshift, and you can just build a model straight out of that you can then call as an API. Okay, so in that case, let me show you the kind of output you get. So I've fitted my model here. It just shows me like the distance to the real values that it managed to get on the training set. And then I can just use trivial time prediction here. Just create a new case, fill in with the variables values, and it will predict me like the house price in the end without doing anything. So I'm just gonna take some data here, for instance. Like I'm cheating because I'm taking a data point from the actual training set. There you go. You submit. Up. And here it is. So it has understood by itself that it's a regression, and my predicted value is 23.5. And if I'm having a look here, like the real value is 24. Well, once again, it's overfitted, but it seems to work. So this is basically like there are, I think, much more libraries or softwares that you could use to actually do that. The power of that is just that you do that, and then I'm not working for Amazon, disclaimer, but you can actually deploy that in a sec, and you'll get a server with your own endpoint that you can trigger at any moment to call like for such a prediction. So it's cool, and it's pretty amazing. Now you can also go like the full manual way. When I say full manual, it's just not coding everything from scratch, but at least using like libraries that work pretty well for that. I'm actually like more of a Python guy, so I've built you a small example working in Python. It's a case of Amazon food reviews. It's maybe a bit funnier as well. It's a classic as well. It's just trying to figure out from the description of a review, like the text, what the rating was. So it may be interesting in the case where you're launching like a new, I don't know, like a restaurant rating application, but you don't want to ask too much to your users, so you just ask him to leave a comment. And you may then be able to predict whether people are happy with this restaurant or not. So you may want to build like a model that's able to predict ratings. So in that case, here it is. Well, basically, I'm just like importing my dependencies here. It's Python. It's just IPython notebook. It's very powerful for making presentation because you can mix up code with text and explanations. So this is what my data looks like. So it's tabular. I have my score here. Okay, between 1 and 5. So it's the rating. And I have my text here. Okay. I'm just keeping these two columns here. And what I'm going to do is just I'm going to train a model whose aim is to predict the score based on the text. So it's a bit different from what we've seen earlier because text is just not structured. Like you don't have like ready-to-go columns. You actually have to build that. So here I'm just looking like very important when doing a model is to always spend some time looking at your data and what it looks like. Whether you have missing values, whether you have like absurd values. Like sometimes you would have rating going 1,000. Ratings are supposed to be between 1 and 5. So this is my rating distribution. So it seems like I think it's 1 million ratings, something like that. A bit less, 500K maybe. Yeah. And so you see that a lot of people tend to skew their rating to 5. Like they tend to overrate. So here what I'm saying is just I'm going to try to build a model which predicts classification, whether rating is above 4, so 4 and 5, or below. So this is my like classification class distribution on my training data set. I have like a lot of 1s and a few 0s. Then I'm not going to go into much detail. I don't know if we have time for that, but I'm just building my model, and this is the kind of output I'm getting. Knowing that my baseline here is 78%, meaning that predicting always 1, so predicting always the fact that the review was positive, gives me a 78% of right predictions, right? So here I'm trying actually to beat that. So I'm just building like a very simple model because the emphasis here is not on doing advanced stuff, it's much more on showing you how it works. And just running my cross-validation I talked to you earlier. So as I iterate on different training and test sets, I get this report. So basically my accuracy in average is 89%. And I see that actually I'm pretty good at predicting positive labels and not as good as predicting negative labels, which is not that surprising because I have not many negative labels to learn from on my dataset. But let's say it's not like here, I'm not here to optimize anything, it's just to show you the way it works. Here I'm just showcasing like the words that account most in the way I classify my reviews. So I would have here the top 10 negative words. So it's the moment where you get to understand that it doesn't work so bad because you have very, very negative words on that side. And on the other side, you have like pretty actually good words, especially for food review. You have yum, for instance. And then what I'm doing is just that once I'm happy with it, I'm just storing my model to disk, and I can then use it in an API. So I've just built like a very small wrapper, which enables me to access this prediction as an API. I can then integrate in any like web service I want. I could build like a Ruby on Rails application and just call my API for predictions. It's one way of doing that. I could also like use a message queuing system or other ways to make a Ruby on Rails application interact with like Python code. Like API calls is definitely something I can do. So if I'm having a look at that, I think I have my server launched, yeah. That's it. So this is actually that. So I just need to input here the text I want to try my predictor upon. So let's just say rate time. Okay. So predicted rating is 5. I have like a 99% chance of it being above 4. Okay. Now it's pretty, like this one is pretty straightforward because I had grades in it, but we can try either negative things or my dog ate this food, but I kinda like it. Okay. I think obviously 80 wins here, but you can then, I mean, here it's just a very, very simple model, but it actually already works pretty well. And you can then actually twist things for your algorithm to understand more context, or like the negation of positive things becomes negative and this kind of stuff. So I think I'm actually done for this demo now. Just to conclude, if you guys have found that interesting and maybe you want to build like things like that and hopefully more advanced stuff, here are a few things that I started on and I think are still really accurate to learn machine learning. First thing is just set to Quora, where I'm actually heading as soon as I have a question. If you manage to get through all the like company disclaimers, you'll end up finding a real solution for your problem. But how do I learn machine learning is just like a good question to ask on Quora. There's just one article which is called "Machine Learning is Fun." I think it's seriously the best article for getting to understand what's happening in like a 10-minute read. It's very, very good. You have 2 parts. First part is just on basic stuff, and second one is on deep learning, and it's actually pretty interesting to read. And there are 3 newsletters, like weekly newsletters, that I try to read on a weekly basis. It's Data Science Weekly, one other which is called Data Machina and Data Elixir. It's a mix of machine learning stuff, computer science as well. You have a lot of computer science topics. And you have also like data science, which is not machine learning, like also about like data wrangling, data cleaning, this kind of stuff. And 2 courses which are like, I think like big classics now. Introduction to Machine Learning by Andrew Ng, the Coursera. I think it's an open class, so you can take it whenever you want. And you also have like I think he has his Stanford videos on YouTube. You can check that as well. And you have an introduction to interactive programming in Python if you want to deep dive a bit more on the Python side on Coursera. So yeah, I think that's it.
Thank you, David. Now, if anybody has a question, wave at me. No?
Hi. At one point, I thought clustering was kind of a classification with multiple, categories. And I would have, I think, in practice, some difficulties to understand which one I should apply if I have different categories, if I should make multiples classification divided by 2 categories and in a row, or just doing directly a clustering.
So actually having access to what we call the label. So it's just knowing, for instance, if we take let's say we have cat, dog, horse, and co. So you have 4 classes instead of 2. You know what pictures is assigned to what class. What clustering would do, it wouldn't take the label into account. It would just group similar pictures together. And hopefully, if you take 4 classes, you may end up having the horses and cats, but without actually knowing it from the beginning. This is a way of it would be kind of discovering your classes without knowing them in advance. In the case where you have the labels, so you have, it's a cat, it's a dog, you know what pictures is assigned to what. You can do classification on multiple classes. So it's not necessarily 0, 1. It can be 0, 1, 2, 3. You can do classification on several classes. You have several ways of doing that. I don't know if it's worth getting into much detail here. But you actually have a big value in knowing the label, because you can actually build a predictive model for these classes. With clustering, you can't really. You're just grouping things together without being 100% sure that they're the same. I don't know if it makes sense, but thank you.
So let's say you have young entrepreneurs in the room. They don't have a clue about machine learning.
Yeah.
What are like the few pieces of advice you would give to them?
I would say get interested, definitely. It has I think in many cases it has huge potential for your business, but you may not know of. So it's just like being aware of opportunities that you could miss. Second thing is just don't overthink what you're doing. Like a lot of people are doing machine learning because it's fancy and not because it brings value to your business. So you may not want to hire like a PhD with 10 years of experience designing very advanced stuff. You may more want to work with someone who's very hands-on and who has like a good knowledge, but also a very practical mindset. And I think that's already 2 advices that I would give you. Thanks.
You talked about the overfitting issue.
Yeah.
Isn't it sometimes a bit frustrating to use like big approaches like this, like something that is very like efficient, but just at the end to end up with a result that was kind of obvious?
Yeah, it happens. Actually, it happens quite often. Like you would spend some time like doing your optimization, like not even your optimization, just gathering data, putting everything in place, and you end up discovering that it doesn't work more than like a very simple modeling or even like a rule of thumb. It's a bit frustrating, definitely. I think in many cases when it doesn't work, it's either that the data is shit, it happens, but it's also that the model, like the variables were not well thought of. It's either that you're missing something, so you have to collect more data elsewhere, maybe try to look around and look for contextual data like open source APIs, this kind of stuff. Or it's even that your variables, like they're too correlated one with each other, or you're doing something wrong sometimes. But yeah, I have no real answer for that, I'm sorry, but it's definitely an issue when you spend time modeling.
I have a question about sample size. How do you know which sample size you need for the testing? Is there a rule of thumb, or how many sample do you need for the testing? Actually,
I mean, it's just more of an habit I have than, I don't know if it's best practice. I'm splitting my data set in 5, and I'm taking 4 parts of it for training and 1 for testing. So like 20% of my data set, but it actually really depends on the size as well. If I have not that many data points, I may reduce the amount of points I'm using for testing. But since you're running cross-validation, you're actually testing on your whole data set in the end, because you're just switching like the part you're using for training and the part you're using for testing. Yeah, so yeah, I think like you can, I think a lot of people split in 3 or 5 the data set and just use between 20 and 33% of all the data for test. Yep.
Another question? Okay. So thank you again, David, for this workshop.
Thank you very much.
And thank you for coming. Don't hesitate to stick around for a few beers and maybe more questions. And also, just for your information, there is another event about machine learning tomorrow. If you're really interested in this and you want to know more, it's organized by OCC, Open Coffee Club. It's also on Meetup. Don't hesitate to check it out. Thanks again.
Thank you very much.